In this video, we will learn about law of conservation of energy. See, the law of conservation of energy says that energy can neither be created and nor be destroyed. Instead, it can only change from one form to the other form. Okay. Now to understand this, let's assume that there is a ball at height h. Okay. This ball is at a height h from the ground, right? This ball is at rest. This ball of mass m is at rest. Now, what will happen is this ball at rest contains gravitational potential energy, that is mgh. As this ball is released from here and it comes here after some time, with speed v, it strikes the ground. All the potential energy would have been converted into kinetic energy, that is half mv square. Yet the total energy would have remained unchanged. Now, what is the total energy? The total energy is kinetic energy plus potential energy of the ball, which would have remained unchanged and is still the same. Now, we will see many examples from our daily life to help us better understand this particular topic. Now, we will study about the total energy of an oscillating pendulum. Now, this will also remain unchanged. Now, I'm assuming that there is no air resistance. What is air resistance? The air resistance is, you can assume, like the air friction. Okay. We will assume ideal condition that there is no air resistance. This is what we say a pendulum is: a rigid support, a thread, and a metal bob tied to it. We will try to learn about three particular positions. Now, the first position is your position number A. Position A states that the bob is at rest and is touched to the ground. Okay, this is at the ground level. This is at the ground level. Okay, now we will have two more conditions. I'll draw these conditions by a different color. Now, this is the second condition, and this would be the third condition. Okay, now this is the B position and this is the C position. Okay, and as you can see that these two positions are h height above the reference or above the ground. Now, as you can see on position A, if I give this ball v velocity in this particular direction, this will go up in a fashion like this. This bob will go like this. And at this particular height, the velocity at B would be 0, which means that at this position, at B position, potential energy is mgh and kinetic energy is 0. At A position, potential energy was 0 and kinetic energy was half mv square. Okay, right? Now the bob will again have some velocity due to gravity, it will fall down, right? At this particular position, again it will go in this direction, and similarly at C, potential energy would be mgh again and kinetic energy would be 0. Let me again write this for you. Here, potential energy would be mgh and kinetic energy would be 0. But as you can see, numerically, the value of this kinetic energy and potential energy are the same. Numerically, potential energy is equal to kinetic energy in this particular condition. Okay, so I can say that in this condition as well, remains total energy remains unchanged. Total energy remains unchanged. Okay, total energy or sum of all energies remain unchanged. Okay, so can we say that the position A to position B, kinetic energy got converted into potential energy, and from position B to position A, potential energy get converted into kinetic energy, and same for C position, right? C and A. So this is how the pendulum oscillates. Okay, now let us see the motion of a roller coaster. So you might have enjoyed the ride on a roller coaster, and a roller coaster works on the principle that the energy of the roller coaster car may change from kinetic to potential or vice versa, but still the total energy of the car remains unchanged. So let me give you a perfect example for this. Let us assume this roller coaster at position A. Now, at position A, we can see, let us assume that there is a potential energy of 10 joule. Okay. Now, as and when it starts rolling, it will get some speed, right? With some speed, we get some kinetic energy. Now, let us assume that at this position B, kinetic energy is 3 joules and potential energy is 7 joules. Now at C position, I can see that the kinetic energy is increasing as the speed is increasing, and the potential energy is decreasing because potential is getting converted into kinetic energy. And at the extreme condition, you can see that all the energy is converted into kinetic energy and potential energy became zero. Now at E position, the speed of the roller coaster is slowing down. So I can easily say that the kinetic energy is decreasing. That the kinetic energy is decreasing. Now, if the kinetic energy is decreasing, it will be converting into potential energy again. Let us assume that at position E, the kinetic energy again becomes 5 joule from 10 joule, and the potential energy becomes 5 joule from 0 joule. Potential energy becomes 5 joule from 0 joule. Now at position F again, the potential energy becomes 10 joule and kinetic energy becomes 0 joules. So as you can see that the potential energy was readily converting into kinetic energy and kinetic energy was readily converting into potential energy, but the sum of these energies remains unchanged, like as you can see in this particular diagram. Okay. Now, production of electricity in thermal power plant. See, in a thermal power plant, we use coal or natural gas. For the production of electricity, there are a series of steps to convert these fuels into electrical energy. In this process, coal is crushed into fine powder and then burned in a furnace or a boiler to produce heat. So, the chemical energy of the coal is converted in a furnace or a boiler into heat energy of steam. Now, this heat is used to transform water into steam. Okay, now this steam will run this turbine. Okay, will turn this turbine and convert the heat energy into kinetic energy. Now, the kinetic energy of the turbine gets converted through this electrical generator into electrical energy, and we get the final electricity we required. I hope this topic is clear to you. Thank you.